Hi, welcome to the fourth and last section of this course. In this section, we are going to talk about one of the most anticipated features of Java 9, the Java Platform Module System, or as it is also called, Project Jigsaw. More specifically, in this section, you'll learn about packages in the Java project and how to create a multi-package project. And then we'll follow up with an introduction to Project Jigsaw, explaining what new features does it bring to the Java ecosystem, then have a short before and after discussion comparing between jar dependencies and the newly introduced modules. Finally, we will look into modularizing our Twitter client Java application and understanding the benefits that this modification could bring. Let's go ahead with the first video of this section, creating a simple multi-package project based on our Twitter processing application. In this video, we are going to look at a comparison between single package and multi-package Java projects and analyze which situations warrant the creation of a multi-package project. Finally, we will switch back to our Twitter client and split it in multiple packages. First of all, let's define what a package is in the Java ecosystem. In the most simple way, a package can be defined as a group of classes with a similar purpose. As you will see later in this course, classes within the same package are usually situated in the same folder. If we would not use the import statement at the beginning of our Java classes, we would have to address every single class using a full name, which is composed of the package name together with the class name. For example, if we're talking about a class in a project with no packages, then the class will only be addressed by its own name. If all the classes in the project are falling under the same package, all of them can be addressed using the package and class name. For more complex libraries and project structures, we will have longer, fully qualified names. That will include all levels of packages that class is situated in. As an example, we have two exception classes, illegal argument exception and file not found exception. The first of which is situated in the lang subpackage of the Java parent package, while the second one is situated in the IO subpackage of the same parent. On this slide, you can see some of the classes that you might be familiar with that are falling in the completely different packages inside the JDK API. Despite the fact that all three of them are exceptions, illegal argument exception is a generic language-related exception, therefore falls under the lang package. Timeout exception has to do with concurrent execution, therefore will fall under the concurrent package of the Java API. Finally, as file not found exception has to do with files and data structures on disk, it falls under the IO package. In the three gray boxes, you can see how each of these classes can be addressed using a full qualifier, and based on this name, we will already know how to search for the source code of these classes inside the JDK source code. Now, moving on, let's briefly discuss a few reasons why we should use packages in a Java project. First of all, and perhaps the most obvious reason, is avoiding naming conflicts. For example, let's assume that file not found exception can refer to both a file on the disk and some file on a shared internet resource such as a website. If you analyze the different reasons why these two can take place, you'll realize you have two completely different classes with the same name, but different behavior. To differentiate between the two, you will have to place them under a different package. Most likely, one package will be IO, and the other one will be an internet-specific package. A second reason is managing access. If you remember the access modifiers of any Java class or function, they can be public, package local, protected, and private. Having classes split in different packages can create a logical separation, and by using the package local modifier, we can control access to the given class or function. A third reason has to do with learning a new codebase and is applicable especially when working with open source libraries in Java. For a properly structured Java project, the learning curve for a developer will be much leaner, since either previous experience or even common sense will tell a developer where a certain class can be found using the right package names. Finally, we need to mention release management. Different packages can be located within the same Java project or within different projects. The separation aspect is up to the developer. If two packages are part of different projects, then they can be released as different libraries independently with little coupling between them. As an example, a bug fix in a single class will not warrant the release of the entire codebase, but only of that certain library including the class, making the whole process much quicker and painless. Going back to our Twitter client, up to now it contained all classes at the same level with no package separation. Given it's a small project, we did not need it. However, to future-proof our application and to better organize our code, using multiple packages is something we should now consider. So far, we have three classes, Twitter app being the main runnable, together with Tweet Publisher and Tweet Retriever. One easy way to split these classes is having the last two of them placed in a commons package, since it's common reusable code, and having the Twitter app class placed in a different package called app to indicate the fact that it represents the actual application entry point. Once we do this, you will notice that we will start addressing the class with the package names and that we will have to use import statements in our Java code. Let's now switch over to IntelliJ to do the actual splitting of our application. This is everything we had to do. Now, let's look back and analyze what have we achieved. We now have a multi-package project with better separation between classes. This may seem redundant now, but if we ever need to write another type of app on top of our existing code, such as a graphical user interface Twitter client, then it will be obvious that a common package will be reused entirely. The separation we have in place will also help developers that may not be familiar with our codebase to quickly identify the classes and their roles. Finally, if we ever decide to separate these packages into different Java projects and release them separately, the remaining work is minimal, since the logical separation is already done.